Dear friends, today we will discuss about the basics of wireless communication. Wireless communication is the fastest growing part of the very dynamic field of electronics communication. What are the examples? TV transmission, radio listening, as well as the police wireless functioning. Let us first take the history of wireless communication. The very first public broadcast of voice and music came in 1906. The commercial radio broadcast started in USA in 1920. The two-way police radio system started in 1930 with walkie-talkie in frequency modulation. Other radio and TV were in amplitude modulation. This was about the public. What was the situation in post-war expansion? After World War II, the AT&T company introduced IMTS, improved mobile telephone service in 1946 for public. The cardless phone, initially in analog, in frequency modulation, in the band of 46 to 49 megahertz. Now, the latest model in digital are either in 900 megahertz or 2.4 gigahertz band. The cheap, simple to use with limited range, and this is that cardless telephone. The second example is the pager. It was introduced in 1962. Pager remained popular due to low cost and small size. This is the pager. These are the keyboards, and this is the text display area. It is very simple in use. The latest is cellular revolution. The first cellular radio service was installed in Japan in 1979, and after that in USA in 1983. These are the example for cellular communications having different types of antennas on the figure. How it works? Cellular systems are quite different compared to normal radio transmission. Here power is kept low and frequency is repeated after reuse distance. In case of radio and TV, the distance between the two transmitters of the same frequency were kept in thousands kilometers. But in case of cellular systems, the two BTS of the same frequency comes within 10 kilometer range. You see this figure, different cells are available here. Each cell has its own transmitter and cover only this area. The second cell, which is this one, it has its own hexagonal boundary. Here signal is not supposed to go outside the boundary of defined cell, and after reuse same frequency is repeated in the form of complete spectrum. If the number of subscribers increases in a cell, then cell is split into a smaller cell. See here the figure, this was the bigger cell, there is small cell, and this is the smallest cell. But all these cells have some multiple of the original cell. Ratio may be half or depending upon the situation, but their boundary is part of the original cell. Personal communication system, PCS. PCS usually operate in higher frequency range of 1900 megahertz. Our cellular system in GSM was 900 megahertz. This is compared to the normal GSM system operating at 900 megahertz band, where data is also higher. The frequency is higher in case of PCS, the data handling capacity is also higher. What are the elements of communication? Without these elements, the wireless communication may not take place, and these things are transmitter, radio channel or radio link, and receiver. See this figure, one side is source, another side is the destination. The transmitter basically is a modulator. Whatever information is available at the source, it is modulated into higher frequency, and through some medium or the channel, it goes from source to destination, which has the receiver. If at the transmitter there was a modulator, then at the receiver there is a demodulator to get back the original information. And what are the ways of link, means channel? This channel may be radio or air, it may be copper, means wired one, or fiber. Fiber has its own advantages. Very high frequency spectrum passes through the fiber optics, and the biggest advantage is it is free from disturbances of electrical signal. There is no effect of electrical sparking or any other disturbances. So, it has the advantage compared to the wired system. So, you have gone through the elements of wireless communications, means transmitter, receiver, and in between the channel. Channel may be air, wired means copper, or maybe fiber optics. Let us see how the communication takes place. The information starts from source via transmitter, channel, goes to receiver, where it is demodulated and reaches to destination. So, this way, this is one way communication starting from source to destination. We have to think about the other way also, from destination to source. That communication may be different one. See how the modulation takes place. The supreme position of low frequency audio signal on the higher carrier frequency is called the modulation. The reverse process is called the demodulation to receive the information. Let us come to this figure. This is the carrier, which is essential part for any modulation, and this is the signal, that is called the intelligence or the baseband. If it is amplitude modulated, the amplitude of carrier is changing. If it is frequency modulated, then the frequency of carrier is varying. So, we have given here the AM means amplitude modulations and frequency modulations, wave shapes. There are three names of information signal. It is also called as a intelligence or modulating signal or baseband, depending upon which part of electronics you are studying. If you are in digital electronics, it is called baseband. If you are in analog electronics, it is called the modulating signals. If you are in communication, name is intelligence. So, elements of communications are well known, the three elements: transmitter, receiver and channel. The process starts from source, transmitter means modulator, passes through the channel and goes to receiver means demodulator, and you get the information. So, you complete your communications. This is called the simplex. Simplex means it is the only one way communication, going from source, transmitter, channel, demodulator means receiver and destination, but not coming back. So, this was the simplex. What are the examples? Radio and TV. From radio and TV, you get the message, but you cannot send back the message. So, this is the examples of simplex communication. Then another type of communication is half-duplex. What is in half-duplex? It do not require simultaneous communication in both directions. Communication is both direction, but not simultaneously. Push button to talk and release it to listen. This half-duplex save bandwidth. These are generally walkie-talkies used by police personnels, and very good example of half-duplex communication. If it is a half-duplex, there will be somewhere the full-duplex. But before that, let us see how the half-duplex functions. This is the working of half duplex communication system. In case of half duplex communications, first goes through the upper channel and the reverse come through the different channels. There are two channels, but operate one by one, and switching takes place through the switch. It allows only one channel to operate at a time. So, this was the example of half duplex. Full duplex means duplex communication. When communication takes place in both directions at once, it is called the full duplex communication. Examples are telephone, wireless mobile communication systems. Here we need two receiver, two transmitter and two channel, as is demonstrated, see here in the figure. One channel is this one and another channel is this one. For first channel, the transmitter, channel and receiver. For second channel, the transmitter, channel and the receiver start from terminal to source and source to destinations. Two identical transmitter and receiver are housed in one system to make the full duplex communication system. So, it will operate in both direction. Example, two persons on telephone, they can talk. There is no hindrance, both the channels are live, voice is passing on both directions. Wireless network, when there are more than two simultaneous users, in telephone only two users, one is sending the transmission, another is receiving the transmission. But when users are too far from each other, for direct communication a star network is required. When the users are more than one. See, this is the elements of communication for star network. Here the central hub is the radio network. This is the central hub. It consists of receiver, transmitter with antenna, cellular and PCS are one of the example of this network. PCS, personal communication system, is the example for this one. It has its own transmitter, antenna, receiver, everything is its own. How it works? Let us see. Through hub, all the terminals, they have the link without any systematic order. Any of the terminal can be connected with the hub at any time, depending upon the requirement. It is not necessary that this terminal first comes and second comes this one. It is the user requirement. Wherever is the subscriber, through hub he can contact. There is no such order that it will start from first, second, third and fourth, but their information will pass through the hub only. It cannot bypass the hub. If you want to talk from terminal 1 to terminal 2, it will not go directly. The information will be routed through hub only. So, this is about the star network, and generally teleconferencing messages in the groups, they take place through the star network. Now, let us study the modulation. First of all, why modulation is required? Can we not send the message without modulation? We can send, but very long antenna will be required depending upon the frequency. Audio frequency is in kilohertz, then antenna will be in kilometers, that we cannot afford for construction as well as for installations. So, lower frequency or intelligence signal is converted into higher frequency, and that is called the modulation. Let us first take a sine wave. This is the sine wave. This is the amplitude part, this is the phase part, and as time passes, more number of waves comes. This is the physical representation of the sine wave. The electronics representation is E t is equal to E c sin omega c t plus phi. What are these things? E t is the instantaneous voltage, this E t. E c is peak carrier voltage, he is talking about this E c. Omega c, carrier frequency in seconds, omega is also written as 2 pi f, and this t which is here, time in second, and the term phi which is the phase angle. Phase angle of what? Sine wave. Here there are 3 variables. In above equations there are 3 variable parameters. Which are the 3 variable parameters? Omega c means frequency part, E t means amplitude part, and phi means phase part. If these 3 are variable, then your sine wave can be varied in 3 ways for modulation purpose. This is the sine wave. For amplitude modulation, it means our purpose is to vary the amplitude. Let us see how we can vary the amplitude. Your amplitude will vary. Here it is reducing. You can increase it also, going the maximum value. Depending upon the situation and in terms of requirement, you can adjust the amplitude of the sine wave, which is to be used as a carrier for modulation purpose. The amplitude will vary depending upon the what type of intelligence means the audio signal you have provided. So, you can change the amplitude. What are the examples or process? This is your audio signal or call the modulated signal. without carrier you cannot modulate. So, this is your carrier, and after modulation the wave shapes becomes this type, where the modulating signal has the positive amplitude, amplitude of the carrier increases. If the amplitude of the modulating signal is negative, the amplitude of carrier decreases. So, this is the amplitude modulation. What is frequency modulation? If you can vary the frequency, means we can change the wavelength. See here, we are changing the wavelength. Higher the wavelength, lower is the frequency. Lower is the wavelength, higher is frequency. So, see here, you have reduced the wavelength, means you have increased the frequency. So, this way you can change the frequency. How this can be utilized for modulation purposes, for frequency modulation? This is your intelligence, means audio signal, and this is the carrier. For amplitude modulation, this was the wave shape of the carrier. For frequency modulation, the wave shape of the carrier has been came in this way. If it is positive side, the frequency is increased. If it is negative side, the frequency is decreased here. Means frequency of the carrier signal is increasing or decreasing depending upon the intelligence information, means audio signal. We have discussed about the amplitude and frequency modulation. Let us see how we can change the phase. Let us first find out the phase. Where is the phase? See this figure, this is the 0 phase. If you advance, it is 90 degree, then goes to 180 degree, 270 degree and 360. Means in 360 degree your complete circle takes place, or complete one cycle of the sine wave is completed. And changing the phase means instead of 0, it may start from any position. Let us see how it is changing. See, it is changing the situation, going from 0 to this side, continuously phase is changing. This is one direction, it may be in opposite direction also. See, it will start from 360 to going lower side. Basic wave shape of the sine wave remains same, but only the phase is changing. So, this was animation about the phase modulation. How the phase modulation takes place? Instead of sine wave, we have taken a digital data in terms of rectangular wave shapes, but basically this is the digital data. Wherever the data changes, the 180 degree phase difference takes place. See here, this was the carrier, and after phase modulations, at the time of either 1 or 0, where the amplitude is changing or bit is changing, a 180 degree phase difference takes place. If it is increasing order, positive side; if it is in decreasing order, on negative side. But after change of bit, means from 0 to 1 or 1 to 0, or number of bits. Wherever the bit change, the phase change. So, this is the phase modulation. In every case, we have a signal which is used to carry useful information, and in every case there is a noise which degrades the signal. It is the noise which deteriorates the information. It passes along with the signal. So, your purpose is to get better signal to noise ratio, higher the signal and reduce the noise. Then what is noise? How it affects? Systems are affected by noise which has many sources. We know that the thermal noise power is proportional to bandwidth. Higher the bandwidth, higher is the noise. Let us see some formula written here. Pn is equal to KTB. What are these terms? Pn means noise power in watts. K is the Boltzmann constant, which is constant value is 1.38 into 10 to power minus 23 joules per Kelvin, fixed value. T is temperature in Kelvin. B, noise band width in hertz, and Tk, that has been converted from centigrade to Kelvin, you use add another 273. So, it is converted into Kelvin. We will give you some example. Let us take some example. A resistor at a temperature of 25 degrees centigrade is connected across the input of an amplifier with a bandwidth of 50 kilohertz. How much noise does the resistor supply to the input of the amplifier? If you see that formula, figures are given here. Put these figures into your formula to calculate the noise. See, first we convert centigrade into Kelvin. So, Tk, see here Tk, that has been converted from centigrade to Kelvin by adding 273. So, it becomes 298 Kelvin, not terms of 1000, but it is Kelvin. Put your values in this formula. You can calculate the noise power. K is 1.38 into 10 power minus 23. T is, you have just received 298, and this frequency or bandwidth is 50 kilocycle, means 50 into 10 power 3. It comes to be, after calculation, 2.06 into 10 to power minus 16 watts. 10 to power minus 16 means very small value. So, this is small power, as received signal is also small. So, you have calculated the noise power. Then come to signal to noise ratio. You want better signal to noise ratio. There are two ways of improving the signal to noise ratio. Either increase the signal or reduce the noise. Both will improve the signal to noise ratio. Increasing the power can affect battery consumption. If you are increasing the signal, means increasing the power, your system will take more battery consumption. The system bandwidth must be large enough to accommodate signal bandwidth. Whatever bandwidth system has and whatever signal is going to be transmitted, it should in a position to accommodate it. Noise in frequency domain means what is white noise. Noise power is proportional to the bandwidth. What it means? Equal noise power in each hertz of the bandwidth. This type of noise is called the white noise, as it contains all the frequencies, just as white light contains all the colors. So, it is called the white noise. Let us see what is the frequency spectrum for radio communication or radio frequency spectrum. Radio does not mean to only the listening the voice. Radio means higher frequency. The radio waves are in the form of electromagnetic radiations. And what may be the electromagnetic radiations? It may be infrared, it may be visible light, it may be ultraviolet light, or even the gamma rays. The major difference is frequency. All are electromagnetic waves, the infrared, visible light, ultraviolet and gamma rays, but difference is in frequency. The spectrum used for radio communication range from 100 kilohertz to 50 gigahertz. So, our purpose is the radio frequency spectrum. We have prepared a frequency spectrum chart to categorize which frequency comes under what category. We have divided frequency designation, frequency range, if it is frequency, what is wavelength, and wavelength designation, what is the commercial name. Frequency will remain same, wavelength will remain same, but we designate in different way. Let us first take. First is extremely high frequency or EHF. What is frequency? It start from 30 gigahertz to 300 gigahertz. This is EHF. And if you convert into wavelength, V is equal to f lambda, V is the velocity of light, f is the frequency and lambda is wavelength. So, you can convert the frequency into wavelength and it comes to be 1 mm to 1 centimeter, and name is called millimeter waves. The commercial name is millimeter waves. The second type of frequency, that is called super high frequency or SHF. The frequency range is 30 to 30 gigahertz, starting from 30 to 30 gigahertz. Wavelength is 1 to 10 centimeter, and this commercial name is microwaves. The next frequency is ultra high frequency UHF. It start from 300 megahertz to 3 gigahertz. Corresponding wavelength is 10 centimeter to 1 meter. There is no commercial name, but it is UHF. It is used in television. Very high frequency VHF. Frequency range extend from 30 megahertz to 300 megahertz, and the corresponding wavelength is 1 to 10 meter. There is no commercial name, but known by VHF. It is also used in TV transmission. High frequency HF range from 3 megahertz to 30 megahertz. and wavelength is 10 meter to 100 meter, and these are called short waves used for radio communication. And medium frequency MF that exists from 300 kilohertz to 3 megahertz, and their wavelength is 100 meter to 1 kilometer. This is called the medium waves. So, this was about the radio frequency spectrum. The wireless communication occupies mainly, talking about wireless mobile communication, VHF, UHF and SHF. These are covered for the wireless communication. You can convert the frequency into wavelength, wavelength into frequency. If you see this formula, V is equal to f lambda, V is the velocity of propagation of the waves in meters per second. What is the propagation speed? It is 3 into 10 power 8 meters per second. F is frequency of wave in hertz, and lambda is the wavelength in meters. So, you can convert frequency into wavelength. Bandwidth requirement. This is a sine wave. What is bandwidth? A sine wave exists at only one frequency and therefore occupies 0 bandwidth. If it is single frequency, no bandwidth. If these are multi frequencies, then bandwidth. As soon as it is modulated to transmit information, bandwidth increases. If you have converted one frequency into higher frequency, means more number of frequencies, you have increased the bandwidth. As per Hartley's laws, there is some Hartley law. I is amount of information to be transmitted in bits per second. K is the constant for signal to noise ratio and modulation scheme. T is time in seconds and bandwidth in hertz. To transmit more information in given time, more bandwidth is required. So, these were the basics of wireless communication. I hope you have understand the lessons. If there is any doubt, please ask your question. You are welcome to raise your questions.
So, my question is, what are the basic modulation methods?
We have defined through sine wave, you can change 3 parameters: amplitude, frequency and phase. So, these are 3 basic ways of modulation. Any other doubt? Yes, madam.
If we double the bandwidth of a system, how noise will be affected?
Noise and bandwidth, they are directly proportional to each other. If double the bandwidth, noise will also double. So, this is the formula, it is directly proportional. Anybody has any other more question?
While thermal noise sometimes called as a white noise?
Because it occupies all frequencies. If it is applicable for all frequencies, the noise is applicable for all frequencies, then it is called the white noise. Any other question? Satisfied? So, dear friends, you have gone through the basics of wireless communication. In this series of wireless and mobile communication, we will discuss in the next lecture the cordless telephone. Till that, Thank you.